Thanks for coming in, David. As I mentioned, we like to focus on practical scenarios here. Let's start with a common one. You've just joined a project, and a specific bean you've carefully configured isn't being injected into your service. The application starts up with no errors, but you get a null pointer exception at runtime. How do you diagnose this?
That's a great question. The first thing I'd suspect is an issue with Spring Boot's auto-configuration. My process would be to first check the conditions. Spring Boot uses @conditional annotations to decide whether to create a bean. For example, maybe it's a @conditional on class, and the required class isn't on the class path, or @conditional on property, where a property isn't set. To see this in action, I'd enable debug level logging for the org.springframework.boot.autoconfiguration package in my application.properties. This will print a detailed auto-configuration report on startup, showing exactly which beans matched and which ones didn't, along with the reason why. If that doesn't reveal the problem, I check the actuator's /beans endpoint to get a definitive list of all the beans that were actually created in the application context.
Excellent. You went straight to debugging the conditions, which is exactly right. Let's talk about environments. We have dev, QA, staging, and production. How would you design a configuration strategy to manage database URLs and API keys that differ across all these environments, ensuring production keys are never checked into Git?
I'd use a multifaceted approach centered on Spring profiles. I'd define base configuration in the main application.yaml and environment-specific overrides in application.dev.yaml, application.qa.yaml, and so on. For sensitive data, like production database credentials and API keys, I would never place them in the YAML files. Instead, I'd rely on a higher precedence property source. The key is understanding Spring's externalized configuration order. I would have our deployment scripts pass these values as either environment variables or command line arguments, as they will always override the properties in the packaged YAML files. To make the code cleaner and type-safe, I'd also use the @configuration properties annotation to bind these properties to a dedicated Java bean. This avoids scattering @value annotations all over the codebase and makes validation easier.
Good. Now, security. We need to build a new set of REST APIs that will be consumed by a single-page application. It needs to be stateless. Outline the steps you'd take to secure it using Spring Security and JWTs.
Of course. For stateless JWT authentication, the core is a custom filter in the Spring Security filter chain. I'd create a filter that extends once per request filter. The flow would be: the filter extracts the JWT from the authorization header on every incoming request. It then validates the token, checking its signature against our secret key, its expiration date, and any claims. If the token is valid, the filter would extract the user's identity and roles from it and create a username password authentication token. Finally, it would set this token in the security context holder. By doing this, we make the user's identity available to the rest of the application for that request, allowing @preauthorize and other method-level security to work, all without needing an HTTP session.
Okay, David, you're doing great. Let's do a quick lightning round on a few more topics. I'm looking for concise, high-level answers. First, @transactional. When might it fail to roll back when you expect it to?
It fails if you call it from another public method within the same class because you're bypassing the AOP proxy. It also won't roll back for checked exceptions by default.
Perfect. How do you fix an N+1 query problem in Spring Data JPA?
Using a join fetch in a custom @query to tell Hibernate to load the associated collection in the initial query.
Best practice for global exception handling in a REST API.
A single class annotated with @REST-controller advice containing multiple @exception handler methods for different exception types to return a consistent REST entity error structure.
And finally, what's a good business use case for AOP beyond logging?
Implementing a custom @auditable annotation. You could create an aspect that intercepts calls to methods marked with it to automatically write an audit trail. Who changed what data and when, without cluttering the business logic.
Very impressive, David. Those are exactly the kind of practical, in-depth answers we look for. You've clearly worked with these tools in real-world situations, not just read about them. Do you have any questions for me?